Okay, here we go. So quick and close. Get out your notes, please. All right, so for today, this is where we left off last time we met. We were talking about converting from one form to another. So we started off with probably the hardest one, which is converting from standard form to vertex form and to intercepts form, right? And converting to vertex form, remember we really had two options. We could complete the square if we want to, right? Go through the whole process of completing the square, and if we do that, we end up putting it into vertex form. Or option B is we could just calculate h, which is negative b over 2a, get a number for that, plug that into the function to find k, get a number for that, and then I already know what a is negative 2, and just plug all that stuff into vertex form. Either way, you can either do it algebraically by completing the square, or you can calculate these values of a, h, and k and plug them in. Okay? So we summarize that by saying that to go from standard form to vertex form, we had these two options, either calculate h and calculate k, or complete the square. If we wanted to go from standard form to intercepts form, that's just factoring, right?
So it's factored?
That's just, yeah, that's the same thing as factored form, isn't it? Intercepts form. Okay. So to go from standard form to factored form or intercepts form, we just factor. Okay? And if we want to graph a function that's in standard form, take your pick. If it's easy to factor, probably the easiest way to do it is by just factoring it. And I know that p would be 9 and q would be negative 4, right? Those are my x-intercepts. So if I know 4 and 9 are my x-intercepts, then the average of those two gives me the x-coordinate of the vertex, right? So if I average those two, I got 5/2, and then I can plug that into the function to get k, and that gives me, the value of k, right? And then I would just, if I know h and, that's all I need. If I know these 2 points and I know the coordinates of the vertex, I just connect those 3 points with a parabola, and that's my graph. Okay? Or if I wanted to, I could do negative b over 2a and plug that in. Either way, doesn't matter. Either way. Okay, so moving on then. What if we want to go, this is where we kind of left off then. What if we want to start with something that's in factored form and move it to either of the other two forms? Like if we want to move it to vertex form, we have some options. We could take the long road, which would be to multiply this whole thing out, right? And then once I put it in standard form, I could convert that to vertex form, just like we talked about earlier, by either completing the square or calculating h and k. But wouldn't it be easier instead to put this in vertex form? We know that p and q in this case are 2 and 6, so if I average those, it's really easy and quick to find h, which is the average halfway in between, the average of the two, which is 4. Plug that into the function, and if I plug in 4 for h, what do I get if I plug it into my function? I get 2 times 4 minus 2 is 2, 4 minus 6 is negative 2, so I get negative 8 for k, and I got it, right? Then I know h is 4, k is negative 8, and I already knew that a is 2, so I just write it in vertex form. Okay? If I want to convert to standard form, that's easy. What do I do? If I've got something written in factored form, a quadratic, and I want to put it in standard form, what do I do? You've done this already for years. Yeah, I just simplify, right? I just expand it out. I just multiply and distribute. And if I do all that stuff, if I just follow PEMDAS, I'm just going to get that, aren't I? Right? If I FOIL this out and distribute the 2, when all the dust settles, I'm just going to get that. I'm not even going to go through it. You guys can all do that. Right? Does that make sense?
Yeah.
Okay? And then to graph it, we already talked about this, right? We'd find 2 and 6 would be my x-intercepts. The average of 2 and 6 is 4. That's going to be that's value of h. Plug 4 into the function to find k, and there you go. He's k. Okay, so to summarize, if I'm going from intercepts form to here, that's just simplify, right? If I'm going from intercepts form all the way up to vertex form, I'm just taking advantage of the fact that H is the average of P and Q, and K is F of H. Right? Okay, and then the last possibility would be if we want to go to standard form. That's easy though. Going to standard form always just means we're simplifying. Right? So all I'm going to do here, actually no, I'm converting from vertex form. So vertex form to standard form means I'm just going to simplify, right? I'm going to follow order of operations. So if I'm simplifying, I'm going top down. So what's the first thing I would do? What's the first thing I'd have to do to simplify this? It's a squared, isn't it? So it'd be the exponent. So there's step one. I'd have to expand out x plus 4 squared, right? X plus 4 times x plus 4. Expand that out. Then I'd have to do what? Then I'd have to multiply. I'd have to distribute the -2, right? Whatever I got when I multiplied, when I expanded out x plus 4 squared, I distribute a -2, and then the last step, yeah, just add like terms, right? Say it again. Let me show you the steps. Okay, so if we look at those steps then, we'd end up getting, let's just color code these. So if I expand out that first part, x plus 4 times x plus 4. What am I going to get if I expand that out? Do you guys remember the trick? Did you remember this trick? And we're going to go through this when we talk about multiplying polynomials, but you've done this before. If we do a plus b squared, do you remember what that's equal to? A squared plus, no, 2ab plus b squared. Okay, that's called a binomial expansion. And like I say, we're going to review that stuff later, so I'm not going to get too hung up on it now. The other way you could do this, we could follow that pattern if we wanted to. The other thing we could do is we could just write it out, and that's probably would be your first instinct right now, right? I know that x plus 4 squared is just x plus 4 times itself, and then I just FOIL it out, right? I distribute the x, so x times x is x squared, x times 4 is 4x, I distribute the 4, and get another 4x, and then plus 16, so I can combine 4x plus 4x is 8x, right? So the first step would be right there's step one, exponents. And you see how I could have gotten that by using this pattern too, right? A would have been an x and B would have been a 4, right? So we would have gotten x squared plus 2 times x times 4 is 8x plus 4 squared, 16. Okay, so here, I'll even circle this up here. So that's the first step is the blue step, exponents, right? Okay, next step is purple, right? So the next step is going to be I'm going to distribute the -2. So when I distribute the -2, I'm just going to get -2x squared minus 16x minus 32, right? And then finally, last step is the orange step. We're going to add like terms. And so we get, when I add like terms, there's only one x squared term, there's only one x term, but those two would combine to -14. Okay? Make sense? Okay, so there's converting to standard form just means simplifying. Okay? From vertex. Converting to intercepts form. Okay, this is unfortunately, what do we have to do here? Well, we'd have to go to standard form and then factor it. Right? There really isn't an easy shortcut for this one. You could work around it, I guess. You could work around it, but we'll go back and revisit this exact idea like in about 3 days. And then there's another way we could kind of legally cheat and get to an answer a little quicker if we're really smart about it. But we haven't talked about some of the stuff we need to be aware of first. That's what we're going to talk about tomorrow. Okay? So for now, converting to intercepts form just means we got to do two parts, right? We're going to have to go, first we're going to have to go to standard form. And then factor, right? Okay, so if we wanted to summarize all that stuff, if we wanted to that's what we get if we did it all. If we converted it to, first we convert it, we simplify it, we convert it to standard form, and then we factor it. So to summarize all that, then, if we're going from vertex form to standard form, I don't know why I keep calling it general form, that's old textbook. That's just simplify using PEMDAS, right? And then to go all the way down to factored form. Go to standard form first, and then factor. And if we wanted to, like, graph something, we already know how to graph those. We've done a ton of that stuff, right? We just identify H and K and A, we graph it from that. Yep. Sure. Right there.
Oh,
Yep. Okay. Okay, and so then all you're doing on the assignment, here's just a couple problems from the assignment. I'm going to give you, you're going to get, for example, if I give you something in standard form, then you're going to have to do whatever it takes to put that into vertex form and factored form. Now, fortunately, these are all pretty easy. There aren't really any inconvenient fractions in here or anything. They're all pretty nice, easy numbers. So you're just practicing the process, right? And you got to go start at standard form and go to the other two. You got to start at vertex form and create the other two, and then just give me a quick sketch. And then you have to do somewhere you start in factored form and give me a sketch and convert it to the other two forms. And that's it. Okay, does that make sense? Okay, without further ado then, go do it. Let you work on that today.